Imagine a mesmerizing cosmic symphony, executed by an infinite ensemble of celestial bodies, stars, planets, and moons, all resonating in flawless harmony. Yet, within this stellar orchestra, a particular segment has captivated astronomers for centuries: exoplanets. These extraterrestrial worlds reside beyond our solar system, concealed deep within the expansive Milky Way galaxy. What may astound you is that among these myriad celestial entities, there exists an exoplanet so remarkably similar to Earth, so strikingly familiar, that it could very well be our planetary twin. Let us embark on a voyage into the fascinating realm of Proxima B, a planet situated a mere 4.2 light-years from Earth. The James Webb Space Telescope is revolutionizing our approach to the search for and comprehension of these enigmatic worlds. Envision, for a moment, that your thoughts drift through the vast astronomical expanse of the Milky Way, a galaxy harboring more than a quadrillion exoplanets. To visualize this, imagine each exoplanet being the size of a grain of sand. Not only would this fill the Grand Canyon, but it would also be sufficient to construct a new geological wonder on Earth, a Grand Canyon 2.0 stretching 4 million kilometers in length. What's even more astonishing is that approximately 20% of these distant worlds have been identified as Earth-like in terms of their geological structure and atmosphere. This implies that for every 5 exoplanets, one could resemble our planet. But the narrative doesn't conclude here. Accompanying these planets could be another quadrillion moons, rocky satellites akin to Earth's own, engaging in gravitational dances with their parent planets. Space.com. If you're anticipating the discovery of another celestial body that could harbor life, or perhaps one that might, then the cosmos presents boundless opportunities. Now that we've begun to unfold the immense scale of the cosmos, it's time to introduce the master artist capable of painting its intricate details: the James Webb Space Telescope. This cosmic detective, with its telescope lens replacing the typical magnifying glass, outshines even the most sophisticated optical instruments. Its 6.5-meter primary mirror, 2.7 times larger than Hubble's, enables it to detect even the faintest star flicker billions of light-years away, analyzing the planets that orbit them. But the James Webb is revolutionary not only for its unparalleled observing power, but also for its advanced technology, which includes infrared sensors and spectrographs. These tools can do more than simply observe. They can analyze the unique light signatures emitted or reflected by celestial objects to decipher their atmospheric conditions, composition, density, and even mass. Acting as space forensic scientists, they can determine if a planet contains water, organic compounds, or even oxygen. The James Webb Space Telescope is not just an upgraded version of Hubble. It's a monumental leap forward. If Hubble's discoveries left you astonished, prepare for an even more spectacular series of revelations as we continue to explore the intricate landscape of the cosmos. One star, in particular, beckons our focus: Proxima B. Since its discovery in 2016, this mysterious planet has become the protagonist of a cosmic tale full of complexity and paradoxes that have intrigued astronomers and researchers alike. What makes Proxima B stand out? For starters, it is located in our cosmic neighborhood, just 4.2 light-years away. To put this in perspective, if you could travel at the speed of light, you'd reach Proxima B in just over 4 years, the same amount of time it takes for a presidential term to conclude or for your favorite TV show to become outdated. But the proximity of this planet is important for more than just practical reasons. It lies within a universe that stretches across 93 billion light-years, so finding a planet so close yet so full of promise for scientific research is like discovering a diamond in a mountain-sized pile of stones. This diamond could hold vital secrets about life and our place within the grand scheme of the universe. Proxima B's allure isn't solely based on its proximity to Earth. Astronomers believe that it may not only resemble Earth but could even be Earth's twin, Earth 2.0. Positioned in the so-called habitable zone of its star, where conditions are just right, not too hot, not too cold, it may offer the possibility of liquid water. Picture waterfalls cascading down cliffs, vast rivers winding through alien landscapes, and oceans as mysterious and deep as Earth's Mariana Trench. However, before we let our imaginations run wild with thoughts of vacationing on Proxima B, we must consider some of its peculiarities. For instance, one day on Proxima B lasts an astonishing 11 Earth days. Imagine sunrises that unfold slowly, heralding a new day, followed by extended sunsets stretching into golden hours that photographers dream of. While this might sound like a dream come true, it poses intriguing questions about the planet's climate and habitability. Would our human biorhythms adapt to this unfamiliar light and dark cycle? Would we need to eat more on Proxima B? Could we sleep in the same manner as we do here on Earth? Life, as we know it, would be both strangely familiar and perplexingly alien. Nature seems to present us with a riddle wrapped in a mystery. Could Proxima B's civilization be similar to ours? A question that tests our assumptions about what makes a planet habitable. But how can we gather accurate, reliable data about a world we've never visited? The James Webb Space Telescope deploys all of its capabilities to answer this question, functioning as a versatile research lab in space. Thanks to its cutting-edge technology, astronomers can not only observe distant planets, but also analyze them with advanced tools. Through infrared sensors and spectrographs, the telescope can examine the radiation emitted and mirrored by these distant worlds. By dissecting the exact wavelengths of light absorbed or released by various substances in a planet's atmosphere, scientists are able to conduct a remote diagnostic, akin to a biopsy, on these extraterrestrial realms. This empowers them to assess atmospheric pressure, density, and the potential existence of life-supporting ingredients like H2O, carbon-based molecules, and even oxygen. The James Webb Space Telescope isn't merely another observational apparatus. It is an analytical marvel. It enables humanity to shift from hypothesis to verifiable data, broadening our cosmic comprehension and altering our perception of what may exist beyond our terrestrial boundary. Just when we thought we had demystified all the cosmic enigmas, a startling development emerged. Researchers utilizing the James Webb instrument detected something exceptional from Proxima B, a signal so unusual and elaborate that it rippled across academic institutions and digital platforms, igniting debates on the likelihood of intelligent alien life. This electromagnetic transmission was unlike any other previously recorded, so detailed and rhythmic that it hinted at the possibility of an advanced, intelligent origin. For an instant, the collective pulse of humanity halted, gripped by the thought that we might not be solitary occupants of the universe. Yet, as abruptly as the signal surfaced, it dissipated, leaving behind a haunting stillness, a surge of speculation, and a trail of unresolved questions. Was it just a fleeting spatial anomaly, a temporary quirk in the cosmos? Or could it have been a subtle whisper from a far-flung intelligence, perhaps a cryptic broadcast, or the lingering echo of a long-lost civilization striving to make contact across millennia? That solitary signal enveloped Proxima B in an aura of mystery, elevating it from a mere object of scientific curiosity to the epicenter of cosmic fascination. The implications are electrifying. Might this be part of a broader, more intricate saga, one that intertwines us with a broader interstellar fellowship? Though certainties continue to elude us, one truth is unmistakable. The mystery intensifies our determination. It fuels more than scientific inquiry. It kindles an intrinsic human longing to reach out, to connect with a presence beyond our own. And the narrative doesn't conclude there. With each leap in technological innovation, the James Webb Space Telescope, no longer a passive watcher but an active celestial investigator, is being reimagined by visionary scientists into what can best be described as an astronomical night vision tool. Their ambitious goal: to scan remote exoplanets not solely for organic signs of life but for evidence of artificial illumination. Yes, light, artificial brilliance, street lamps, urban skylines, entire civilizations aglow under alien sunsets. Visualize the awe, a bustling extraterrestrial society emanating energy into the universe, detectable not by biology but by engineered luminance. A metropolis shimmering across the dark hemisphere of a foreign world, a synthetic glow piercing through the interstellar void. It may sound like the stuff of speculative fiction, but it's swiftly transitioning into empirical reality. Such a discovery would be monumental. Detecting artificial lighting wouldn't merely confirm the existence of intelligent life beyond Earth. It would imply a pattern, a universal rhythm, life and intelligence as a cosmic recurrence. And what would such a finding mean for us? It would rewrite philosophical doctrines, reframe theological beliefs, challenge geopolitical perspectives, and reshape scientific paradigms. In a single breathtaking instant, we would cease to be the isolated offspring of Earth and become, instead, members of a vast, perhaps ancient, galactic legacy. New questions would arise, questions deeper than any we've previously dared to pose. How would we establish communication? What insights could we gain from them? And most profoundly, how do we redefine us once we are aware that they exist? But for now, we remain on the edge, on the brink. The James Webb Space Telescope continues its celestial quest, peering deeper into the cosmos, unraveling atmospheres, and exposing secrets that have slumbered in the quiet of space for eons. Every spectrum it deciphers, every brightness fluctuation it studies, inches us closer to answering those ultimate questions. Are we alone? What else populates this boundless universe? And might there come a day when we call another distant sphere home? This is more than investigation. This is epiphany. As we stand at the gateway of this extraordinary epoch, let us remember, the cosmos is not merely immense. It is vibrant with enigmas, awaiting revelation. And with the James Webb Space Telescope guiding our pursuit, we are no longer passive spectators. We are active participants in the discovery of our destiny, one star, one signal, one world at a time.